Have you ever wondered how your body just knows how to stay at the perfect temperature? You walk out of a warm building into a freezing winter day, and instantly things start to happen. You get goosebumps, you start to shiver, or think about a scorching summer afternoon. You start sweating without even thinking about it. It's almost like you have a smart thermostat built right into you, one that's far more advanced than any device you could buy for your home. This internal system works tirelessly, 24/7 to keep your body running at its optimal temperature, which is right around 37 degrees Celsius, 98.6 degrees Fahrenheit. It's a biological masterpiece of engineering, constantly making tiny adjustments to protect you. This process is called thermoregulation, and it's one of the most critical functions your body performs. All the chemical reactions that keep us alive happen most efficiently within a very narrow temperature range. If your body gets too cold, these reactions slow down dangerously. If it gets too hot, proteins can start to break down, causing massive damage. So, how does your body pull off this incredible balancing act, keeping you stable whether you're trekking in the snow or relaxing on a tropical beach? The answer lies deep within your brain, in a tiny but incredibly powerful region. The complexity of this system is truly astounding. Understanding how this system works is key to appreciating the incredible resilience of the human body. So let's pull back the curtain on this biological magic show. Are you ready to meet the boss? Deep inside your brain, nestled at its base, is a structure about the size of an almond. It might be small, but don't let its size fool you. This is the hypothalamus. It is one of the most important control centers in your body. Think of it as the CEO of a massive corporation, overseeing hunger, overseeing thirst, overseeing sleep, overseeing body temperature. It's the master regulator, the central hub. It receives information from all over your body. It sends out commands to keep everything in perfect balance, homeostasis. Your hypothalamus is your body's primary thermostat, set point 37 degrees Celsius, or 98.6 degrees Fahrenheit. Its job, constantly compare actual temperature to the set point. It relies on an army of informants, thermoreceptors. You have receptors all over your body. Some are in your skin, your first line of defense. They tell your brain when the outside world is hot or cold. Others are deeper, monitoring blood temperature in your core. The hypothalamus is divided to handle heating and cooling. The front part, anterior hypothalamus, your cooling center. Think of it as the switch for your internal air conditioning. The back part, posterior hypothalamus, your heating center. It activates when your temperature drops. This division of labor triggers the right mechanisms at the right time. It prevents sweating and shivering at once. Skin thermoreceptors send constant updates. Core thermoreceptors send constant updates. The hypothalamus compares incoming data to 37 degrees Celsius. This feedback loop runs constantly, making tiny adjustments you don't notice. Imagine you've stepped outside on a brisk, windy day. A sudden cold gust hits you. Your skin receptors immediately fire off an urgent message to your brain. Temperature dropping. This signal travels straight to the command center, the hypothalamus. Specifically, it's the posterior hypothalamus, the heating specialist, that receives this alert. It instantly recognizes the threat of hypothermia and springs into action. Its first order of business is to prevent more heat from escaping your body. Keep the precious warmth inside your core, where your vital organs are. First command, vasoconstriction. Vasoconstriction equals narrowing your blood vessels. The hypothalamus signals tiny muscles around arteries near the skin to contract. That tightening reduces warm blood flowing to your skin, to your hands, to your feet. By keeping warm blood near the core, heat loss to the cold environment drops dramatically. That's why fingers and toes feel cold and look pale first, a brilliant immediate defense. Next, piloerection, goosebumps. Posterior hypothalamus sends signals down nerves to tiny muscles at hair follicles. Erector pili muscles contract, hairs stand on end. In furry ancestors, this trapped air for insulation. It trapped a layer of air close to the skin, creating a natural insulating blanket of warmth. For modern humans, it's mostly an evolutionary relic. Meanwhile, the hypothalamus also stops sweating. It sends a clear signal to halt sweat glands. Sweat glands shut down. Sweating is the body's primary cooling mechanism. It uses heat to evaporate the moisture from your skin. In cold, sweating would leach warmth away rapidly. So the hypothalamus puts a firm stop to it. By constricting blood vessels, raising hairs, and halting sweat, the hypothalamus bats down the hatches to conserve internal heat. But what if that's not enough? If conserving heat isn't enough to bring your temperature back to the 37-degree set point, the posterior hypothalamus moves on to its next strategy. generating more heat. It needs to turn on the furnace. The most obvious and effective way it does this is by initiating shivering. You've definitely experienced this before. That uncontrollable shaking isn't just random. It's a highly coordinated, deliberate act orchestrated by your brain. Your body is about to become its own heating system. The hypothalamus sends signals to your motor neurons. Muscles contract and relax in rapid succession. This rapid muscle activity is thermogenesis, heat production. Every muscle contraction burns energy and produces heat as a byproduct. Shivering involves large muscle groups all over your body: jaw, teeth chattering, arms, legs. This involuntary workout can increase heat production up to 400–500% above resting. It's powerful but temporary. It brings core temperature up from a dangerous low. Shivering shows your body's resourcefulness. Your muscular system, normally for movement, is repurposed for life-saving heat. But it's energy-intensive. It burns through glucose. It burns through fat reserves. You feel exhausted after prolonged shivering. Not sustainable long-term. It's an emergency response until you find shelter. Shelter, a warm fire. When you feel that first uncontrollable shiver, recognize it. It's not weakness, it's your hypothalamus working perfectly. Your brain's automatic defense turns muscles into tiny furnaces to protect organs. A primal, effective survival reflex keeping you warm and alive in a cold world. While shivering provides a quick blast of heat, your hypothalamus also has a slower, more sustained strategy for warming you up. This involves the endocrine system, your body's network of hormone-producing glands. Let's explore this chemical approach to staying warm. When the posterior hypothalamus detects a prolonged drop in temperature, it sends a signal to the pituitary gland, which signals the thyroid gland. The thyroid gland releases thyroid hormones into your bloodstream. This process is called chemical thermogenesis. These thyroid hormones act as a system-wide accelerator for your metabolism. They instruct your cells to increase their rate of metabolic activity, converting fats and sugars. Just like a car engine running at higher RPM, faster metabolism generates more heat as a byproduct. This is a much more enduring way to raise your body's temperature compared to shivering. It's your body's way of settling in for a longer cold spell, ensuring steady warmth from within. Beyond automatic responses, the hypothalamus powerfully influences your behavior. When you feel cold, it's not just physical sensation, it's a motivational drive created by your brain. The discomfort urges you to take action. Curling up into a ball, putting on a sweater, seeking shelter from the wind, making a hot cup of tea. These behavioral changes are your first and best line of defense. Long before shivering, your hypothalamus nudges you to grab a jacket. This integration of physiology and behavior makes the system robust. Your brain actively drives you to solve the problem, using your conscious mind as its most powerful survival tool. Now, let's flip the script. It's the middle of a sweltering summer day. The sun is beating down. You're starting to feel uncomfortably warm. Just as your skin has cold receptors, it also has warmth receptors that detect this rise in temperature. These receptors send an alert to the hypothalamus. Sensors in your core monitoring blood temperature also send alerts. The signal goes to the cooling center, the anterior hypothalamus. It recognizes hyperthermia and needs to act fast. The goal: release excess heat and return to 37 degrees Celsius. First action, opposite of cold, vasodilation. Blood vessels near the skin widen. The small muscles around these vessels relax, allowing more warm blood to flow to the surface. Your skin becomes a giant radiator. Heat dissipates into the cooler surrounding air. Your skin often appears flushed or red, a visible sign. The anterior hypothalamus simultaneously inhibits the posterior hypothalamus, telling the heating center to stand down. Shivering is suppressed. Chemical thermogenesis is halted. Cooling and heating can't happen together. That would be dangerous. This ensures one coordinated response. Your brain also taps into behavior. Feeling hot creates a powerful drive to cool down. Find shade, turn on a fan, turn on an air conditioner, take off extra layers of clothing, drink a cold glass of water. When vasodilation isn't enough, the anterior hypothalamus unleashes its most powerful weapon: sweating. The brain signals millions of sweat glands to produce and release sweat, which is mostly water and some salts. The real magic happens through evaporation. As liquid sweat turns into vapor, it draws heat directly from your skin. This evaporative cooling is incredibly efficient at shedding massive amounts of body heat. It works best in dry conditions where sweat can evaporate easily. In humid environments, the air is saturated with water vapor, making it harder for sweat to evaporate. This is why hot, humid days feel more oppressive than hot, dry days of the same temperature. From the biting chill of a winter storm to the oppressive heat of a desert, your body maintains its core temperature at 37 degrees Celsius. At the heart of this performance is the hypothalamus, your brain's small but mighty thermostat. This command center orchestrates a symphony of responses, telling vessels when to tighten or relax, muscles when to shiver, glands when to sweat. This integration of physiology and behavior is the secret to our survival in virtually any climate on Earth. Without a properly functioning hypothalamus, we would be incredibly vulnerable to temperature extremes. The next time you shiver or sweat, appreciate the miracle within you. It's not a flaw, it's a sophisticated system protecting you. Your hypothalamus is your silent, unsung hero, the vigilant guardian ensuring internal stability. Your hypothalamus will thank you for helping it out.